The Earth's surface has changed a lot over the past 4 billion years, but there is one thing that has remained constant. Our home planet is covered in oceans. In fact, around 70% of Earth's surface is underwater. And while we have maps of the ocean floor, what's actually beneath those depths remains largely a mystery. But one recent discovery suggests that these watery depths may be hiding something explosive. Keep watching to find out what shocking fuel might be powering some of the world's most dangerous volcanoes. Earth's oceans are so vast and deep that they can seem almost alien-like. For example, there's a place called the Mariana Trench where the ocean floor is nearly 11,000 meters deep. That's deeper than the tallest mountain on Earth, Mount Everest. The pressure at the bottom of this trench is more than 1,000 times greater than the pressure we experience at sea level, and the temperature is just above freezing, so it's hard to imagine anything living down there. But scientists know that giant squid and other creatures do make their homes in such inhospitable conditions. But they're not the only things that might live in such extreme conditions. Now let's go back to the beginning, when Earth was a much hotter place. Our planet formed billions of years ago when a cloud of gas and dust collapsed in on itself due to gravitational forces. Most of the heavier elements were close to the center of this cloud, which eventually became the core, and lighter elements gathered at the top, forming the crust. Now Earth wasn't the only thing that formed out there. There were also smaller rocky bodies that started clumping together. Some of these became planets like Mercury, Venus, Mars, and Jupiter. Others became chunks of debris that remained trapped in orbit around the larger planets. These small rocky bodies are known as meteorites, and many have come crashing into Earth over the eons. These impacts weren't always gentle either. In fact, scientists think that one massive impact early in Earth's history may have been the reason why our planet now has an iron-nickel core. It's thought that a planet-sized body about the size of modern-day Mars smashed into Earth around 4.5 billion years ago. The collision was so violent that some of the material from both planets was blasted all the way out of orbit. Over time, this debris collected in the newly formed Pacific Ocean. Eventually, this water would evaporate and leave behind solid minerals, including iron and nickel, which settled at the bottom of the ocean basin. These materials were so dense that they sank through the lighter rocks in the Earth's mantle, and eventually reached the core where they mixed with existing metals. This mixing may have generated so much heat that it melted part of the core, allowing lighter elements like sulfur to escape and form a sulfide-rich layer between the inner and outer core. The remaining iron-nickel mixture solidified and created the Earth's new core, which has remained relatively unchanged ever since. In other words, this ancient impact may have been the reason why Earth has a molten outer core that generates our planet's magnetic field and protects us from deadly solar winds. This same impact may also be the reason for another feature of our planet, our oceans. You see, Earth wasn't the only thing that got blasted out of orbit during the collision. A significant amount of debris was thrown into space and eventually fell back to the planet as meteorites. Many of these rocks were rich in hydrogen, oxygen, and nitrogen, which reacted with each other and other elements after they hit Earth's surface to form acids. These acids then reacted with minerals on the surface to form salts and other compounds. Eventually, Earth's gravity pulled enough of these particles together to form a thick atmosphere. Eventually, the air cooled enough to allow water vapor to turn into liquid. And by 4 billion years ago, Earth had its first ocean. But that's not the only way that these collisions shaped Earth's surface. Impacts can also leave massive new craters in the crust. Sometimes these become filled with water and form lakes. Other times, entire sections of land can collapse into these holes. When this happens under the ocean, it creates deep trenches in the sea floor, and scientists think that these features may play a major role in supervolcanoes. Supervolcanoes are different from regular volcanoes. They can be up to 1,000 times larger. While most volcanoes are formed by magma pushing up from the planet's interior, supervolcanoes form when magma pushes up against a fault line, a weak point in the Earth's crust. The magma pools under the seafloor and forms a magma chamber. As more magma accumulates, the pressure increases until the crust can't hold it all in anymore and the supervolcano erupts. Take, for example, the Toba supervolcano located in Indonesia. Around 74,000 years ago, this volcano erupted violently, sending around 2,800 cubic kilometers of ash and pumice into the air. That's about 300 times larger than the Mount St. Helens eruption in 1980. This eruption was so massive that it left a crater that's around 100 kilometers wide and 500 meters deep. So what makes Toba and other supervolcanoes so dangerous? Well, when these eruptions occur underwater, huge amounts of magma are suddenly released into the ocean. These sudden changes in temperature and pressure can trigger massive landslides and tsunamis. And because the volume of material involved is so great, these events can affect climate patterns all over the planet. For example, in 1980, St. Helens erupted and sent ash as far away as Canada, and the Toba eruption may have sent ash as far away as Australia. But despite how devastating these supervolcano eruptions can be, they're surprisingly rare. And according to a new study published in Nature Geoscience, they may be even rarer in the future. That's because the team of researchers discovered something quite surprising. Beneath the seafloor near the Tonga Island arc in the South Pacific Ocean, they found evidence of several large magma chambers. The researchers used seismographs to listen to how earthquake waves moved through the seafloor. By analyzing the data, they could identify areas where magma had pooled beneath the seafloor. They found 3 magma chambers that were over 50 kilometers long and contained tens of cubic kilometers of magma. This discovery is important because it helps scientists understand the plumbing systems beneath the ocean floor. It can also help them figure out if these magma chambers are connected to nearby volcanoes. For example, the researchers found that one of the magma chambers was connected to the Volcano, a potentially active volcano that's located along the Tonga Island arc. But here's the surprising part. The team of researchers noticed that all 3 magma chambers were located along a fault line that cuts across the seafloor. And this fault line connects to a much bigger fault line that runs for more than 1,000 kilometers through the ocean. So why is this important? Well, for a supervolcano to form, magma needs to pool beneath a section of seafloor that's relatively intact. Magma can easily escape through a fault line and won't accumulate in large chambers. The researchers think that the big fault line running through the ocean may be preventing supervolcanoes from forming in this region. And that's not the only thing that surprised the research team. They also noticed that the fault line appeared to be moving in the opposite direction that it had been moving in the past. In other words, the fault line that's normally creating new seafloor is now pulling old seafloor back into the planet. This means that magma can pool beneath the seafloor and potentially trigger supervolcanic eruptions. So does this mean that we should keep an eye on the Tonga Island arc? Not necessarily. The fault line cutting across the ocean isn't exactly close to any populated areas, but the researchers hope that their discovery will help them better understand the processes that trigger supervolcanoes, and that knowledge could prove vital in the future. There are more than 40 known supervolcanoes on Earth, and many of them are located near major cities. For example, Yellowstone National Park sits atop a supervolcano in Wyoming, so it's important that we learn as much as we can about these geological giants. If we ever want to predict when they might erupt, we need to know what fuels them in the first place. And according to a new study, that fuel may come from the deepest parts of our oceans. Now watch supervolcano eruption may have led to the extinction of dinosaurs. Or check out this video instead.